we will have the chance to listen to speakers who have worked on such fascinating objects as obituaries, classified ads, or even readers' letters sent to newspapers. So, as before this morning, please ask your question in written mode in the chat. And as before, questions will be moderated and answered during the Q&A session at the end of the presentation. So now let's come to the content of our presentation. And giving the floor to Vera Maria, or Nenad, who is a trained musician, historian, specializing in plain chant, and she is currently studying digital humanities at the University of Graz. And Nenad Pantelic is an economist with a focus on institutional change and economic libraries. They are about to present their work on the Austrian labor market as seen through the classified ads. So I don't know, Vera or Nenad, it's up to you.
Good morning. Is my audio functioning? First question. Can you hear me?
Yeah, that's perfect.
Can you see the presentation?
Yeah, too.
Perfect.
It's up.
Okay. So Nenad and I will be your presenters today, and I will just. So, good morning, dear colleagues. Thank you very much for the opportunity to talk about our work in progress on the topic of incredibly differentiated labor market, evidence from job offers. Our project is part of the research network HFDT, Human Factor Digital Transformation, which is situated at the University of Graz. Study how job advertisements historical newspapers reflect the job market, focusing on Austria from the midst of the 19th to the midst of the 20th century. We use digitized historical papers for our case study. Today, we want to learn experiences in the conversion of those digitized newspapers into a corpus ready for text mining. Note that all this is still a work in progress. We're right in the middle of it. Nenad Pantelic and I, Vera Maria Charvat, we are part of a highly interdisciplinary team of researchers from the fields of digital humanities, economics, sociology, and system science.
Vera, sorry to interrupt you. Your sound is very, very poor.
Okay.
Maybe you could come closer to your micro.
I'm holding the mic right in front of me.
It's really better now.
Okay, I don't know where I can change the settings.
It's quite okay now.
Yeah, 1 second. I'll just try the other. Sorry. Okay, I don't know what to change.
I think you can proceed now because it's really better than before.
Second. Oh, I have. How should I change? This is better, I guess.
Yeah.
I can't do anything else. I can shut the volume. I hope.
I think it's quite okay now if you speak directly into your micro.
Okay, I'll try to.
Just like this. Yeah. Thank you so much.
Okay. So I was right in the middle of the introduction. So we are under the supervision of Jörn Kleinert, Manfred Fülsack, and Georg Vogeler. And we have been working together since September and October 2020, respectively. Why job ads in particular? Job advertisements as sources are good indicators of the role that work played and plays in society. They provide information about changes in the perception of work as well as the organization of the labor market over a longer period of time. We aim for 3 goals. Firstly, we intend to generate a unique data source for empirical analyses in various fields of humanities, assuming that job ads, particularly classified ads in newspapers, are a great source of individuals' wills, wishes, and offers widely unfiltered by others. While we focus on labor relationships, the potential is certainly much larger. Secondly, we want to illustrate the strong change in labor relationships in many dimensions, such as extent, regional reach, sectoral focus, skill requirements, job characteristics, self-perceptions of employers and employees, and expected and/or pretended relationships. We expect to detect significant changes in these dimensions over the long time horizon. And thirdly, we want to test and further develop digital methods for text mining and text analysis on this huge database of advertisements with fairly heterogeneous content and structure. As you might have seen on the other slide before, we use digital methods for data generation and analysis in order to accomplish our goals. And we are creating a unique and easily reusable data set, which we will test with small social science research questions. This, of course, requires careful data preparation, which is not always easy. Our tasks include finding these relevant pages which contain job ads, run region detection programs to separate the job ads from other newspaper contents, and finally to OCR the ads. And as soon as we have a good data set as ground truth, we can start with data analysis using and evaluating machine learning methods. The base of our study is Anno, the virtual reading room for historical newspapers and periodicals of the Austrian National Library. And my colleague Nenad Pantelic has now prepared some interesting statistics for you. Nenad, please.
So I hope you can hear me. So I'll tell you some basic statistics about the Anno corpus. So the corpus of the Anno repository consists of about 1,000 different historical newspapers and magazines, all from the former countries of the Austro-Hungarian Empire. And this is about 1.5 million editions, which is about 22 million digitized pages. And about 90% have been digitized over the period from 1689 to some 1947. And for our projects, we are focusing on those from 1800 onwards. If you look just at some very basic statistics about the whole Anno corpus, you can easily see then that about 95% of all editions are newspapers editions, and magazines make up only a small percentage of the data set. Most editions are in the German language, about 93%. And the other languages are Italian, Polish, and Czech languages. Please notice that also newspapers from former countries of the Austrian-Hungarian Empire, like the Praga Abendblatt, were also written in German back at that time. 71% of all our editions can be found in the period from some 1820 to 1918. And it is especially the period in the middle of the 19th century till the Second World War, which is rich in data. Vienna is by far the most important place of publishing. About 42% of all editions were printed in Vienna. Now to our focus on the Anno corpus. So we found out that only some 40 journals have more than 10,000 editions. And the top 10 include newspapers, some of you know perhaps, such as Wiener Zeitung, Innsbrucker Nachrichten, or Neue Freie Presse, as you can see in the table. And most other newspapers have much fewer editions, and we focus on these top 10 papers. Now let me give you a brief look, closer look into the things we have already accomplished. and the problems that we encountered on our way. So our first step was to manually select newspapers which would come into the considerations. So as I said, we decided to go with the aforementioned top 10 Austrian newspapers. And therefore, we first simply browsed through the newspapers looking for job advertisements, looking for human accessible patterns, publication patterns, similarities and variations, simple keywords, so just to get a feel about how the newspapers are structured and where job ads are. In the second step, we then used algorithmic detections of pages where we knew that these pages would contain ads. And even a simple keyword search with the OCR that was provided by the ANO website did okay, because we found over 70% of the selected pages which were expected to contain ads that they actually did contain ads. However, we noticed two problems. First, there were a lot of relevant ads regions in the page that didn't contain any of the keywords that the algorithm found. So this is partially due to bad OCR for these regions. Another reason could be that our keyword search patterns were not exhaustive and we missed some of the results therefore. Second, sometimes the keywords that were found in the page did not appear in any of the ads, but they appeared somewhere else in the general text of the page. And this is of course problematic because it implies that the success of finding the right page might be just a coincidence. Now in the first steps, we will then train classifiers where we combine the existing so-called dirty OCR and the images, but this third step is still to be done. So let me get a bit more into this issue. So another big problem we had was layout detection. What looks quite logical to the human eye often isn't the same for the machine, obviously. And our first attempt was to use the Tesseract standard model for the layout detection. But we came across some significant problems. When we compared the OCR text for the page and the OCR text extracted for the regions annotated manually, it became apparent that words recognized in the annotated regions do not always appear as such in the page's OCR. This is likely because the OCR algorithm layout recognition often incorrectly slices the regions, causing the relevant ad regions split into different blocks regions, as you can see in this page, in these pictures on the page we provided you. Another approach was to use Transcribus for the layout detection, which was a bit better than Tesseract, but often ignored the vertical borders of the columns. As you can see here, the text lines are crossing the 4 columns. And yeah, that's the problem. Vera will now show you some newspaper pages and explain you also why OCR and layout detection have these many problems.
Yeah, thank you, Nenad. So there are different kind of problems which make it difficult to define a common set of rules. First of all, there is a great variety in the headings of the columns. So job applications can be found not only in a specifically titled column like freie Stellen, meaning free positions, or offene Stellen, meaning open positions, but also in other places with a wide variety of titles such as Vakanzen, vacancies. As you can see, we have here an example from Neue Freie Presse from 1880. Of course, a column having a heading does not automatically mean that you won't find job ads in some other places as well, because sometimes there are even no headings at all. So the job ads can be very well hidden between commercials, advertisements for apartments, but also applications or requests by people looking for work and advertisements from even job agencies. In addition to that, during the long time span, starting around 1800, the layouts, the styles, fonts, and font sizes changed. And they did that not only across the various newspapers, but also within a certain newspaper. So those fancy frames, icons, and letters you can see were of course meant for the reader's eye, but unfortunately not for the OCR, which is having problems. Not to forget is the paper quality, meaning that letters would bleed through thinner paper, and among other things, of course, the scan quality. So in order to be successful in the text mining of the ads, we decided that we could obtain better results if we segmented the regions containing individual ads prior to applying the OCR or perform OCR for a second time on those extracted regions. And the most time-consuming thing we had to do then was to manually draw boxes with the annotation software Super Annotate around the headings, job offers, and searches. Those would be those three classes in purple, green, and blue we have here. You can see those colorful boxes. And we've manually annotated 715 pages across 10 different newspapers in this manner, creating 16,790 boxes, up until now. After that, new attempts with Tesseract and transcribers using the manually annotated boxes followed with more promising results. And not surprisingly, the Tesseract output with the models trained on the ONB material worked the best. As you can see here on the right-hand side is the result of the ONB trained model. In addition to all those things we have already done until now, we're also using text mining as an OCR support. And first step is to clean messy OCR results using fast text and the Jaro-Winkler similarity based on the following assumptions. A, misrecognized words appear in the same context as the correct words. B, correctly spelled words are dominant in the word embeddings. And C, fast text character-based embeddings further aid in finding the correct words. So our process is to firstly cross-check the OCR results with the German dictionary in order to get the misspelled words. Then correct single letter mistakes with a high Jaro-Winkler threshold. Thirdly, we generate word embeddings with fast text and calculate the vector similarity of the first 30 words, close in the word embeddings vector space to those misspelled words, and apply the Jaro-Winkler to select the best candidate. Finally, we insert the correction into the corpus and use this cleaned up corpus for the classification task. So, yeah.
So, to sum up, our main goal, the creation of a new and unique data set that is particularly useful for this kind of labor market studies and studies on the perception of work, is possible. This is the good news. But in order to get there, we have to go beyond the standard Tesseract OCR layer detection, which we already did to some degree. And we already achieved some success also with word embedding based edit distances, which incorporate word embedding into edit distance. And we are improving on these results right now. That's where we are right now. Yeah. So that's all from us, and thank you very much for your attention, and please ask us questions.
Thank you so much. Thank you so much, Vera and Nenad. So now our last presentation will be given by Rastinger and Matthias Schlögl from the Austrian Centre for Digital Humanities and Cultural Heritage. They are going to present to us the DIGITARIUM project and their work on name entities recognition and name entities linking. Nina or Matthias, are you ready to present?
Yes, we are. Thank you. The slides are just uploading. Yeah. So can you now see my slides?
Yeah, perfect.
Okay. So thank you for the introduction and of course for the opportunity of talking about our work in progress here. So as the slides already states, Matthias Schlögl and I will talk about the DIGITARIUM as a research corpus and approaches to extracting and linking named entities from this specific newspaper corpus. This is a project we are currently working on at the Austrian Centre for Digital Humanities and Cultural Heritage, together with Claudia Resch and Dario Campasca. So the key issue of our talk today is the enrichment of historical newspapers, which can be considered a general goal when dealing with digitized newspapers. This has already been proven by the multiple mentions of the topic in the talks of the conference, for example, yesterday. So the important step here is probably less to ask why should we do it, but more to ask how. So our key question would be how can digital collections of historical newspapers be further enriched using data from other digital portals, data collections, and knowledge resources. To learn more about this, we have been working with one concrete newspaper corpus, namely the so-called Wienerisches Digitarium. This digital corpus consists of 332 full-text issues of the historical Wiener Zeitung, all coming from the 18th century. The name of the corpus is a play on the former name of the Wiener Zeitung, as it was called Wienerisches Diarium from its founding year in 1703 until 1780. The Digitarium currently contains around 6,000 pages, which corresponds to around 3 million tokens. All these full texts were created with the help of the tool Transcribus, through which we trained a specific model for the historical Wiener Zeitung. This model is also available online if anyone is interested. Also, the results of this process are given, and they are given as XML files, all following the well-known TI standard. Within those files, we have already made some structural and typographical annotations. For example, headings and list items have been marked, but also the change between Gothic font and Antiqua. So if you want to know more about the project or the corpus, just feel free to follow the links given on the slides. But for now, maybe the question is, why is the Digitarium important for our presentation? And this is the case because it is important in the context of the current Vienna Time Machine project, which is led by Claudia Resch and is funded by the city of Vienna. So here the central idea is to establish diachronic connections between people, places, and events within Vienna. And of course, here for the Wiener Zeitung, and thus the Digitarium, offer highly valuable textual material, as they very often contain news about local events. For example, one particular kind of event that the historical newspaper features in almost all of its issues from the 18th century is the death of people, inside and outside the city center of Vienna. These occurrences are published in the form of obituaries, in which all deceased persons are listed. And these death lists, or so-called death lists, are used as a starting point for the Vienna Time Machine project because of multiple reasons. For example, they are part of almost every issue of the newspapers, as already said. But also their structure is relatively consistent, so both over time and within one issue. You might already see this on the picture given on the slide on the right. But another advance of them is that many important details are published per deceased person. So what is, for example, always given is the name of the deceased person, their place of death, and their age when they died. And occasionally also their title, their marital status, and their cause of death is added. So just to maybe give you a quick impression, this is what the same list from the slide before would look like in the Digitarium. So as you can see on the left, it is given in a synoptical view with the full text and the facsimile next to each other. So the user is provided with both. And what is also shown here on the right side of the slide is an exemplary XML snippet for a single list entry, which is here marked in yellow. So it is interesting that if we take an even closer look at this single list item, we can see how much information about a specific event, namely here the death of Matthias Placht, this very short text already contains. So here we have the name of the deceased, Matthias Placht, but also his occupation as a guardsman, his last location at Salzkreis, his cause of death, namely hot fever, and also his age of 40 when he died. So we have many pieces of information which can, especially when they are extracted from a multitude of list items, of course, help deepen our understanding of early modern Vienna and its society. At the same time, however, of course, one needs to pick a place to start out of all these different puzzle pieces. So in our case, this is the place names or toponyms, which we will focus on first. This information should be systematically extracted from the full text. Thus, as a first task, we have named entity recognition. And then as a second step, the extracted location data should be linked to an external corresponding data set. For this task of named entity linking, we have decided to use the Wien Geschichte Wiki first. This is a resource which I will now briefly introduce. So the Wien Geschichte Wiki could roughly be translatable to Vienna History Wiki and is a knowledge resource founded by the city of Vienna. In its essence, it might be comparable to Wikipedia, only the important factor is that it exclusively contains entries which are connected to Vienna and especially to the city's history. So currently the platform contains over 47,000 of such entries, and it also provides users with maps of Vienna and further biographical references. Of course, concerning the place names, which we are especially interested in at the moment, two categories of those entries are especially relevant, namely on the one hand, the 11,500 entries for topographical objects, and on the other hand, the 7,500 entries for buildings. These constitute an interesting comparison set for the toponyms we want to extract from the Digitarium. Ideally, the end result of this linking process would then look like the following slide. So here users of the Digitarium would only be one click away from additional information about a place they are interested in or get interested in by reading. And hereby they would also not only be provided with factual information, but also with map data, as the WGW has geo-referenced and visualized many of its topographical entries on a digital map of Vienna. This can also be seen on the slide in the right corner. Hence, through this, the usability of the Digitarium would be significantly higher. And also additionally, from our point of view, we would end up with a list of toponyms which are connected to Vienna and which could then in turn be used to find and cross-link the same entities in other historical texts. So this way, in the end, the vision of a Vienna time machine could be realized even further. However, of course, as the project is dealing with a newspaper from the 18th century, there are certain challenges for named entity recognition and linking. For example, one would be the high amount of linguistic variation in historic German, due to which one place can be denoted by a number of written forms. The table given on the left demonstrates this problem quite well, I'd say. So for example, for Spittelberg, the normalized version in the WGW, we have a multitude of mentions in the Digitarium. And moreover, we also have other problems, for example, the outdated names that might occur. So for example, the Kärntner Bastei is nowadays named Augustiner Bastei. And also there is a multitude of abbreviations that are part of the analyzed newspaper texts. These are especially problematic as they are often not easy to decode. For example, when the I in the first example here can stand for in, im, and ir, which all have totally different meanings, among other things. So in summary, the textual characteristics of our corpus are rather problematic for named entity recognizers, which are focusing on modern material. Thus, we are currently testing another approach, which Matthias will now present you with.
Okay, thanks, Nina. Can you hear me?
Yes.
Yes, I'm trying to share my screen. Can you also see the screen, the presentation?
Yes.
Yes. Okay, so as Nina said, we are currently exploring a kind of different named entity recognition approach. Namely, we're starting with rules rather than a machine learning based approach from the very beginning. That's especially as Nina also mentioned that already, these lists are quite regular, so they have a very regular format. So we started with a rule-based approach, and we implemented that in the named entity or in the NLP library Spacey. And so we created rules basically, and we evaluated these rules by annotating actual data in Prodigy, and then evaluating what the rule-based entity ruler annotated in these lists against what Nina annotated in the data. And so the next step in our approach is to evaluate these rules and see how accurate they are. And this is where we are currently. I'm sorry. And currently, as you can see up here, we evaluated rules on roughly 150 items. And there, the F-score is at 0.81, which is kind of okay, but could be a bit better. So we're currently still seeing where we can further improve the approach. But what you also see is that the precision is already at 0.84, which means that from the items that the rules found, 84% were actually correct. The recall is a bit lower, which means that we are missing some of the items that could have been annotated. However, so after further improving the rules, we will decide how to go on. And one of the possible paths is that the rules are not accurate enough, and then we will use them as a kind of a bootstrap model for training a machine learning algorithm, and use a combination of the rules, so what the rules annotate and the machine learning model annotate, for creating cases to feed into active learning algorithm approach, and then further improve this machine learning algorithm. And if we get close to, let's say, F1 0.9, we will just stick with the rules. Yes, so the current approach, Nina showed before the XML. The current approach is that the current pipeline is that we import the XMLs into Python objects. And from these Python objects, we create Spacey doc elements where we add all the metadata of the XMLs, namely the XML IDs of the item, list item, and also the file names. And within the list, then we use the W tags that you also saw before from the XML for the tokenization of the document, and also add these XML IDs again to the token element of the Spacey doc. That's so that we can always go back into the very the detailed word of the original XML if we are evaluating our pipeline. Yes, and so the actual pipeline works that way that we have this. So we first create from the XML list item, the doc element, and then we apply roughly 300 rules that Nina came up with that are mainly using regular expressions to the doc element to the document. Then we do some post-processing on the spans that these rules extract from the actual text. So they extract spans of tokens from these list items, and we do some post-processing things like removing in, auf, and other fill words. And then what we get are several annotations of the same on a list item. And a lot of these annotations will overlap, as several of the rules will annotate the same toponyms in the text. And so there is an harmonization step at the very end of the pipeline that runs through all the annotations that the different rules found and harmonize them into final annotations. This is, for the moment, not very sophisticated. So basically what we are doing is putting all the annotations together and see what is the biggest annotation to get the most, the bigger part of the toponyms. Yes, and then I will show you a bit what we found in the data so far. So we have around 13,000 of these list items. So one list is one def of a person. Then in these list items, we found about 15,000 places, because in a lot of the well, in several of these list items, there are 2 places or even more places annotated. And out of these 15,000, we have about 6,500 unique toponyms. And we also found in 12,000 of these entries the age for the person, and the age lies actually between 0 and 109, which is pretty high, I think. And you can see here on the right side a bar chart of the age of the person. So on the x-axis, you see the age, and on the y-axis, you see the number of mentions that we found. What is interesting is that there is a lot of children in the lists, and also you can see here in the middle of this bar chart that obviously when they didn't really know the age, they were using numbers like 40, 50, and 60. That's why we have these high numbers for 40, 50, and 60 ages. And just for showing you one of these possible items here, I put here the entry of the oldest person that we found in the list. She died at the age of 109 in dem Brandweinerischen Haus bei dem Paulator. Yes. So next steps for the project will be to, as I said before, further improve the rules and also the XML parser, because it is not so easy as it may be sound to create from the deeply annotated and structured XML a doc element, a spaCy doc element that completely fits the original, and then reevaluate these rules and see if they are accurate enough. And if they are not accurate enough, so if we do not get close to a F1 score of 0.9, we will use these rules as bootstrap models for training and machine learning based named entity recognizer, and use a combination of the rules and the model for increasing our accuracy. And we will then need to create a named entity linker for places. This is what also Nina already mentioned before. So there are 2 big problems in this thing. The first problem is the normalization. So getting from Salzkreis to the actual Salzkreis that we will find in some gazetteer, either the Wien Geschichte Wiki or GeoNames or something else. And the second thing is the problem of the disambiguation. So even if we can normalize the toponyms to the contemporary spelling, we still have the problem that, for example, the Kaisergasse here was a street in the 8th district, and it is still a street in the 15th district, and maybe even in other districts. So to find which Kaisergasse actually was meant in the list item will be a big problem. Yes, and then another, the further step would be to create similar pipelines for the cause of death and the occupation, so that we can see that we can get distributions of death causes, places where they occurred in Vienna 18th century, and also the occupations that these people died with. Yes, and then obviously create and publish a linked open data set of the data that we created. Yes. that's about it. Thank you very much.
Thank you both of you, Nina and Matthias, for this presentation. So now we have plenty of time to ask questions to our wonderful presenters. Don't be shy. We have a 20-minute QA session. Do we have a question from the audience? Not yet. I may ask to start with. I must ask you, Nina and Matthias, the first question. How are you planning to tackle this this challenge of normalization and disambiguation you just talked about?
Yeah, so we were discussing basically two approaches so far, and we have looked into one of them actually. So one would be SoundX-based algorithms for comparing or for finding the changes of letters actually, and we looked into the CAP, which implements the SoundX algorithm, and to see if they would, if the CAP could normalize toponyms like Salzquiz, for example. That wasn't very successful so far, I think. And the second approach that we were discussing would be some fast text character embedding approach, but there the problem is that we would need actual training material of already normalized data that we don't have so far. And as the project is pretty small, we won't have the time to manually normalize